Hello, good people. It's been a while since we ever had a class. Wengine wananiuliza mwalimu, kwani ulienda wapi? As you can see, mwalimu anaota jua. I've been good. I just noted that my audience are mostly in boarding school. So give me a good reason, you who is watching me, who is in this school, for me to be making content when you are at home or when you are in school. So now that the holidays are here, I'm going to move up running to make sure that I help the guys who are in Form 4 revise for their KCSE. Someone is asking, mwalimu, na wapi huko kuna jua? Si tukuje huko? Hapana, I'm telling you, hii jua ni yetu, so wewe ukae huko ambako kuna baridi. This one we are not sharing. So today I have a lesson with you. We'll be looking at linear motion, and I'm going to divide it into 3 parts. Part 1, where we're going to talk about graphical analysis. Then part 2 about relative speed, and part 3 again about relative speed, but in a different level. So make sure you give me a like so that we continue with our lesson. So the figure below is a velocity time graph for a car, not drawn to scale. So the y-axis represent the velocity while the x-axis represent the time. So we talked about this graph when you are dealing with this in linear motion in Form 2 or in Form 3 in physics. So when you talk about linear motion, you are talking about the area under the curve or under the graph. Or when you're talking about the distance traveled, sorry. So the area under the curve is actually equal to the distance traveled by the car. That is what we established in class, and therefore we got to know what this shape represents. And in this case, these are trapezium. And how do we get the area of a trapezium? It's a half a plus b times height. So in this case, we have the base as 24 and the other length as 16. We multiply by the height, which is 80, and we get the area of the trapezium, which now represent the distance moved by the car. So on multiplying, we get this is 40. 24 plus 16 is 40. 40 by 40. So we'll be talking about 40 by 40, which is 1600. So anytime we encounter such a question, it's always about the area under the graph. Which shape is that, and which formula do we use? And if there are many, we subdivide them into parts, and then we can add the areas. So 1600 meters is the distance traveled by the car. So calculate the deceleration of the car. When is the car decelerating? It is between 20 to 24 seconds, where we have the slope of the graph being negative, and we need initial velocity, which is 80 kilometers per hour. For this case, it is meters per second, and the final velocity. So the vehicle is coming to a stop. So we are talking about 0 meters per second. And then the time it takes to come to rest, that is between 20 to 24. So we are talking about 24 minus 20, which is 4 seconds. And then we are going to apply the formula for the acceleration, which says acceleration is equals to final velocity minus initial velocity. You divide by the time taken. And for our case, the final velocity is 0, the initial velocity is 80. So therefore, we are going to have 0 minus 80 divided by 4. and you'll get to know that the answer we get will be negative. Why negative? Because we are calculating acceleration. There is no exact formula for calculating deceleration. So when you get an acceleration being negative, automatically you are supposed to know that this is deceleration when we drop the sign. But if the sign is not dropped, then that's acceleration. So therefore the deceleration will therefore be 20 meters per second squared, having dropped the sign. So when we give it as acceleration, we should say acceleration is equals to negative 20 meters per second squared. So there should be the squared sign. And that's how we get to find the area under the graph or interpret the graph